Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about phenolic ether. So you can see the question, if you heat this molecule, what is the product? 4 options are provided student and one of them is the right answer. I request you please pause the video and try by yourself, and don't worry whether your answer will be right or wrong, because self-evaluation is essential for improvement, and that's why you should try. And you should not be worried, because after some time you'll get the right answer with proper explanation. I believe you have tried by yourself, so it's my turn to give you the right answer. Now, before going to details, just look at this molecule and reaction condition. Actually, this is a simple heating student. No reagents are given, so which makes your life simpler. So you have to say what is the product after heating, and actually this reaction is student Claisen rearrangement. Okay, so what happens? Actually this Claisen rearrangement is 3,3' sigma stropic reaction, and this Claisen rearrangement happen on this allylic, means you may consider this allylic ethers here. So allyl vinyl ether, and here phenyl vinyl allylic ether. So this is actually a ether of phenol. And how I can say that this is 3,3'? So if you count this 1, 2, 3, then another counting will be 1', 2', 3'. And how this reaction happens? Obviously, this double bond, you can consider that this activates, so this double bond attacks here, it can come, so you may consider that it will come here. Fine. So in this way, or I guess it is little complicated, so you may consider that it will attack here, it will come, and this will come. It is far more easier, I believe. So in this way reaction happens. And see, at the last stage here, this carbon oxygen double bond formation means here aromaticity lost. Okay, and that's why some emergent energy is needed for this reaction, means heating is essential. So in this way aromaticity is lost, but here is one deuterium, and we know deuterium has similar chemical property like proton, and it could be abstracted, or means you may consider that it could be shifted from here to there, means if it is abstracted, then this bond pair will come here and it will open. So ultimately this will produce this OD, and the equilibrium for this keto-enol tautomerism, so equilibrium for this keto-enol tautomerism prefers to go to the enol side in this case. Why? Because the final product, this product has aromaticity, means it is stable. So that's why reaction will happen. And since here deuterium was there, so in this case this deuterium shifting to phenol will, so OD will be prepared and reaction will stop here, because remember this Claisen rearrangement is ortho-selective, and if this ortho position is blocked, then only para substitution occurs. So reaction will stop here. So what is the product? Obviously this ortho substitution, means this option B. Now if this question appear in your exam less than 10 seconds, I repeat 10 seconds, how can you solve? You need to understand that this is a Claisen rearrangement, 1 point, and second, this Claisen rearrangement is ortho selective, and if ortho is blocked, then para happen. And here it is deuterium, it's similar like hydrogen, so don't worry. So first it will go to ortho, then deuterium will move. So ortho and deuterium will move, so this one. So you don't need to even think about those others. Para, since Claisen rearrangement is ortho selective, so para substitution option gone. Now here, and now another thing, question how this proton it will get. No solvent, nothing is given, so only option B is the right answer. Now, so in conclusion, what you have learned today, that Claisen rearrangement is 3,3 sigma tropic rearrangement. It is selective method for ortho substitution, and it is important as carbon-carbon bond formation possible. Previously there was oxygen carbon bond, after this reaction there is carbon-carbon bond formation. And in this context the hydrogen and deuterium are isotope together, because they have almost, means because they have same number of protons in their nucleus, only difference is that one neutron in deuterium. That's why they have almost similar chemical property but different physical property due to the mass, mean exchange of atomic mass. Now, enol content of phenol is near about 100% due to aromaticity, and this aromaticity is huge stabilization energy. But generally, remember, for this keto-enol tautomerism, this equilibrium prefer to remain in the keto side. So this is an exception. And finally, the tautomerism or prototropy. Why this prototropy? Because in this case, proton or deuterium shifting is happening. So that's why, means here you should call deuterotropy. So in case of hydrogen, this is called prototropy, is a phenomena of proton transfer, or deuterotropy means deuterium transfer. So this is the end of discussion. I believe this video may be useful, and I thank you all for watching. And if you really consider my contents are worthy, then please help this channel to grow. So see you in my next video.